Hello everyone, I'm Gyanendra and welcome to today's session. Today we'll be discussing about a very simple topic of physical chemistry. It depends if it is simple or is it difficult. It on you. We'll just be discussing a question or two maybe. And it would be based on the questions that you could get in a competitive exam like IITjee. Without further delay, let us just go into the question. As you could see already on the screen, you have this question. Just imagine this question could also be imagined and understood. You have traveled to another planet. Now you as a student, along with your friend, being a chemist, you have traveled to another planet. And over this planet, you've gone to watch a movie, but you're a chemist. Think that in mind, keep that in mind. So you have reached a place where there is a theater. The theater isn't of the same kind as you would normally have, as on Earth we have it. There the theater is cylindrical. And you just have two small openings. After the audience go in, there are just two small openings left, or the doors are closed, only two small air ventilators, you could say. That kind of openings are there. Now these small openings are used by you there to insert some gases. You along with your friend, assuming you are Rohan and your friend is Soham, this guys or you two guys, one of you are trying to add this N2O gas. This is that gas which you might have encountered when you've gone to a dentist. You'd have observed that this guy would give you something that we refer to as laughing gas. And this is that gas which when you would inhale, you'd start laughing. So this is the reason why we call it a laughing gas. It is literally a gas that makes you laugh. Yeah. N2O is that gas. On the other hand, from the other side, this guy is even more mischievous, like how every student is. So this guy had added weeping gas. Seeing his friend is adding laughing gas, he had this thing in mind. Let me add something that would make people weep. The tear gas he has added. Okay. So the formula that are written over the bottom, that is the formula of the weeping gas. Assuming this is the formula and the mass is given to us, or we could easily calculate if you know the formulas, you have to find out. This is one more thing here, that the audience wouldn't be watching the movies in the same way as we do on Earth. They are lying down on this platform which is made for them to lie down, and the movie is being projected over the roof. As you can see over the image, this is where the movie is being projected, and this is where the audience are lying, right? Assuming that the audience and movie is being projected over this particular position, when this laughing and weeping gases are being added from both the corners of the room, you'd reach a point at a particular time when both the laughing gas and weeping gas would meet there. So this is that row where the audience would both be laughing as well as weeping at the same time. The question says, if the total distance of all the places where the audience could lie down is just 300 meter, and the distance between each of these two rows where the audience would lie down, that is 1 meter. We have to find out what would be the distance from Rohan when or where the people would both be laughing as well as weeping simultaneously. So we need to calculate that distance from Rohan's side, or from the laughing gas side, where people would be both weeping and laughing at the same time. Assuming this side to be x, let us just understand how could we think of answering this. Many people would have different ideas. You guys also might be thinking of something. But the first thing is, this is the only data that we have. Using this data, we have to think of something. So to know this or to solve this, the way you have to think is very simple. We have to calculate x. We would not be given with this, but we know the total distance is x. That would mean the other half of it would be obviously 300 minus x. So this is going to be the other side. Assuming this is a cylinder, you would have certain radius as mentioned over here. This would be the radius of the cylinder. And if this is the height, you could obviously assume this whole thing here particularly is obviously going to be the height. It looks like it is the breadth though, but if you'd keep it vertically, you'd call it a height. You guys should also keep this in mind, that the volume of cylinder is pi r square h. Before starting the solution, these are prerequisites that you should be knowing. Going further, let us just understand what could we do. So we could just imagine, when the gas goes in, what happens to the gas? Gas doesn't stay there. It starts spreading. It starts diffusing. So this process of diffusion is the key of solving this question. all that we have to need is just this diffusion. So what you need to do here is you need to use what is diffusion. Rate of diffusion of any gas is inversely proportional to its root over molar mass. Yeah, and if it is proportional to its root over molar mass, you could simply use this basic idea that rate of diffusion of the laughing gas, that is N2O, over rate of diffusion of the weeping gas is going to be equal to root over the molar mass of the weeping gas upon root over the molar mass of the laughing gas. So this is simply going to be equal to root over molar mass of weeping gas, as they are inversely proportional, by root over molar mass of laughing gas. Yeah. So that is going to be the formula that you have now. So this is the first thing that we have, guys. So this is one of the equations that we have come with. Now that we have got an equation, we could move further to get to a better idea, right? So with this, obviously you can't solve the question because you don't know the rate of diffusion. What you only know is just the molar masses. With that, you can't solve it. So we need something that could give us another cue, another stimuli, another thing that could make us move further towards the answer. What could that be? That can be another relationship of these variables that you have over here, and that is, rate of diffusion is equal to the volume diffused over time. It is simply the volume of substance diffused per unit time, or at in a particular interval of time. So this is another equation for rate of diffusion. And obviously, whatever thing that come across us, if it is usable, we would use it for our betterment. So this rate of diffusion of laughing gas over rate of diffusion of weeping gas, from the relationship that we just saw, could be written as the volume of N2O over volume of weeping gas. Now volume of N2O is simply pi r square h, and volume of weeping gas is going to be pi r square h dash. Now what is r square, what is h dash? This is what we would have to know. We have seen that radius over the whole cylinder is going to be same, but height that weeping gas would have traveled is obviously x, because that much would have diffused in that time, and height for which the laughing gas would have diffused is obviously the other part of it. Like if total height is h, half of it would be the part traveled by the weeping gas, and rest of the half would be the one traveled by laughing gas, to reach a point where both the people would be laughing and weeping at the same time, right? You could just imagine the scenario how these people would be if they're both laughing as well as weeping at the same time. Like there'd be crying, and like there'd be happiness in them. It's rare to see this kind of situations though, but that's a different thing. Coming back to the point, so you have to know what this h is, right? So this here is one of the h, and this would obviously be h dash, right? You already have the radius equal from both the sides. So we got an equation over here, pi r square got cancelled out, h is x, and this is 300 minus x. So x over 300 minus x. Now this is the second equation that we have. This is rate of diffusion of N2O. This is simply the rate of diffusion of N2O over rate of diffusion of the other thing, that is the weeping gas. Now we have got two equations with us, the first equation over the top, the second equation over here. Using this two equation, we can simply make an idea. We could come to a conclusion. What is that? Let's just move to that. That conclusion, that idea is simple. X upon 300 minus x is simply equal to root over molar mass of weeping gas divided by the root over molar mass of laughing gas. I hope you're getting the idea. How easy is it if you are able to predict what are the things that you could use in order to get to what you need? Yep. So this divided by molar mass of the laughing gas, that is N2O. Yep. If that is the catch, you just need to replace the values. So x over 300 minus x is going to be equal to root over molar mass of weeping gas, which you could just see over here is given to be 155. Yep. So it is root over 155 divided by root over 44. That has also been given to us. If not also, it's not a big deal. You could just add the masses to get to this. Yes. Now if this is the case, you could simply be using this to get to final conclusion. and that is x over 300 minus x is equal to root over 155. 12 square is 144, 13 square is larger, right? So it should be somewhere around 13 point or 12 point something. Let us just imagine it to be 12.6. On the other hand, root over 7 square is 49, 6 square is 36. It's like somewhere near 36 and 49. It's more towards 49, so it's like 6.6 or something. So these are the values, like you could just approximate, because in competitive exams like IITjee, the major thing that you would lack is time. So every small moment of time you would need to take up or save for yourself, so that you could like maybe put up that time in any other question, topic, subject whenever in need. Going further, this could easily give you the value of x, like 6.6x is equal to 12.6 times 300 minus x. And this is the question which even a 6th, 7th, 8th or 9th standard student could easily solve. It's an equation with how many variables? You could just yourself see. Only one variable. So it could easily be solved to get to the value of x. So you could just see a question that is of a level of IIT Advanced could easily be solved just by a simple approach. Yeah. And if you look at the question, you could see that there's nothing much given except for two gases and the total distance. Everything that has been calculated is by the idea that has been produced by whose brain? Your brain. That is the way, children. That is the way we approach this. Yep. Now let us move towards an organic chemistry question. Now that we have got an idea of how to deal with physical chemistry, your physical things, your physical knowledge has improved a little bit. But how would you improve the organic? Organic, if you want to improve, you need to work on the organics only. So let us just do that. Here the question says, which place the following in correct order of their acidity. Now they've given CH, CH2, COOH, and then there is this thing. So if you observe one thing that is common over here, you could very easily understand the idea. Like you just see over the first one. Okay, here there is a mistake. There would be one more bond. There's a mistake in the question. There would be one more bond over here. Now if you have a triple bond over here with COOH, and if you have a double bond over here with this thing, you would have COOH, and the last one is like CH3, CH2, COOH. You could just observe one very simple thing. This carbon over here is sp hybridized. This carbon is sp2 hybridized. And the third one, children, the one which is directly attached to carboxylic acid. You know what an acid is? Something that gives H plus easily, especially the carboxylic acid one. It is something that could give you H plus easily. A proton donor is generally an acid. Yeah, you have some other acids also, like the Lewis acids. But here, because you're all the options that you are seeing in front of you, they're all acids having a proton. So we are actually talking about protic acids, acids that could donate a proton. So coming back to the point, this is sp3 hybridized. Now let us just see or think of a case when you get a cake, children. Let's say if it is your birthday, you've got a cake, and you have to divide it into parts. You've got 3 cakes, okay? You've got 3 cakes, and you have to divide these cakes in parts. The first cake you've divided into 2 parts. Just listen to me and understand the scenario here. The first cake you've divided into 2 parts. Okay, the second cake you've divided into 3 parts. The second cake is divided into 3 equal parts. It's not a symbol of any kind of car company or something, or maybe Linkin Park. It is just a symbol. The third cake is divided into 4 parts. Equal parts, Now, if you'd see, where would you get the largest part to eat? Obviously, if it is a cake that we would like to eat the first cake, because that would just be divided into 2 parts. So the shares that we would get would be larger, and we would be much more happier. So this part particularly can be understood as S and P. Dividing a cake into just 2 parts with equal proportions. Here, the character S is going to be much larger. Much larger than the comparative other cases. You just see over here. If you see the other 2 cases, you can see the amount of anything over here, the amount of S character in the second and the third cases are very smaller. Like in the second case it is around 33%, in the fourth case it is around 25%, right? But the p orbitals are like much larger than that. If you observe the s character in the first case, it is 50%. So if you compare the s character between sp2 and sp3, you could simply understand using the example of this cake that we could eat when later on, if you could give me a party, we could eat. Coming back to the point, this sp3 here would have the least amount of s character. On the other hand, this sp over here would be the largest amount of s character. Having the largest amount of s character would mean having electrons more in the s orbital or closer to the nucleus. Why closer to the nucleus? S orbital electrons are obviously closer to the nucleus than any other orbital. That's a very normal funda that you guys would have already heard of. If not, you could yourself think of here. S orbital is s orbital because there is highest amount of attraction, looks spherical in shape, right? Stays closer to the nucleus. That is the reason why this is going to be the most electronegative, and this is going to be the least electronegative of all. Assuming this, we could easily solve this question. You know, an electronegative group would stabilize the negative ion formed when H plus gets lost from an atom. So if you just see over here, which one could give you most stable negative ion? You can just see over here, CHCOO minus, CH2, COO minus, CH3, CH2, COO minus. It is obviously this one which is going to be the most stable. The reason being, more electron withdrawing group is there. That withdraws the electron density and stabilizes it. Comparatively, the other two are going to be less stable. Since the product is more stable, this substance over here could readily lose H plus. And because it loses H plus very easily, this here is going to be the most acidic one. I hope this made sense and you guys were able to get something constructive. This is what we have to do today and we had done today. Now you can understand it and could use these ideas to, improve the work which you're doing yourself or your subject. So keep on studying well. All the best. Take care. Thank you.